All right, let's do this. So the first thing that we want to do is basically we want to make another printing function, but that prints out with a fixed width so that everything can be aligned nicely. So we're going to go print, we'll just call it print width. I don't care. Const char s and int w for the width. So what it's going to do is it's going to print out a string, and then it will print out spaces after that to make it so that the total width of characters printed is at least W. So what we want to do is we basically want to do print. We want to do print, but we want to count how many characters we print. So let's go int c, let's go int n is equal to, that's not an equals. Okay. Keyboard, you gotta work with me here. Keyboard, fingers, whatever. So every time we put a character out, we go in plus plus, and then after we're done, we do for, as long as n is less, as long as n is less than w, n plus plus. And we're going to put out a space character. We'll just put that out like this and forget that L there. Okay, so this is going to print a, let's call it print fixed. It's going to print a fixed width string, or fixed if the string length is less than W. If it's greater than W, then of course it will not be fixed anymore. All right. So just a nice little utility function to get us started. Now, we're going to have a database, right? So let's make a class for that. Class database. Now the database is going to have entries. So let's go class entry. And every entry is going to have a car. We'll just put this as name. Let's do static const expression. Name, let me see. Name buffer size is equal to, and let's just say names, we'll give them 16 bytes. We got, obviously this has to have a type, so we'll give it int. 16, is that enough? 8, 10, let's say 10. So that means you can have, the name can be at least, at most 9 characters long. And then we'll put a name buffer size. And we are going to have int value. All right, so we've got a class for the entry, and that is inner class of database. Public, private. Now, database, static const expression, int, max number entries. So the max number of entries, and let's say you can have a max of 16 entries. That seems like a good number. So now we're going to have a entry, entries, max number entries. So we'll have an array of entries, and int current number entries is equal to 0. All right. So we got a database. We're going to keep track. We've got an array, and we're going to keep track of how much of that array is currently being occupied, much like we did in the SNCC game, if you remember. So of course, this can be done easier with vectors, but we're not allowed to use vector for this. We're only allowed to use what we've been shown in the last couple of videos. So what are we going to do with our database? Well, constructor, we don't need a constructor. We can use the default constructor. That will be fine. What we do want is a function. So we have a default constructor. let's just create that again. So we'll go database is equal to default. We'll create another constructor, database. And what are we going to do? No. We'll have no other constructors. We're going to have instead functions to load and save. So what we will do is we'll create a load function, void load. Const, get fucked, man. Const car pointer to file name. So we'll have a load function, void save. Const car pointer to file name. This one should be const because it's not going to modify the object in any way. And yeah, so load, save. What else are we going to have? Let me think here. We're going to have one to print, and that's going to print out the graph. So void print const, and we're going to have one to add an entry. So void add const car pointer to name int value. So we load, save, print, and add. I believe those are all the operations that we need for the database. Now for the entry, what are we going to do with the entry? Well, we are going to need to create, trying to think here. Create a constructor for the entry. So we'll do default constructor, and then we'll do another constructor, and this one is going to take const car pointer to name int value. And what we want to do in this constructor is we want to set the value to the value that was passed in. And this is very important. You'd never set the, well, you can't set const name. You can't do this. What I'm trying to say, you can't go name. It doesn't make any goddamn sense. You can't change this array pointer thing to point to this, because you can't do that with arrays. That's not how arrays work. So what you got to do, well, let me just do this for a second here. Yeah, so you can't do it. But what we can do is we can copy the string pointed to by this pointer into our buffer here. And the way we're going to do that is we're going to create a function called string copy. So void string copy. Now normally const car pointer to p source and car pointer to p destination. Now normally if you want to be safe, you'd add another one in here, int max size or something like that, so that you don't overflow your buffer, but we're not going to worry about that shit. We are going to be unsafe today because, yeah, whatever. I believe the original string copy, there's a function called string copy, and I believe it is not safe either. The one that's in the standard library. So we're going to just go with the standard, although we're not going to use it because that's not part of the rules. So how do we copy a string? Well, all we do is we go for, whatever, as long as p source, as long as star p source is not equal to 0, p source plus plus p dest. Get fucked. I am so mad with my keyboard and everything. All right, and then we do p destination is equal to p source, like this. And when we exit here, we got to do one more. P destination is equal to 0, so we add the null pointer at the end and the destination buffer, and this will copy a string from source to destination, and everyone will be happy unless we overflow our buffers. So don't do that. Now we want to copy. How do we copy? Well, we just go str copy, and p source is going to be the name. P destination is going to be this pointer to name, because I named them the same thing. So this is the disambiguation. Is that the word? I don't think that's the word, but anyways, maybe it's the word. So now we can construct an entry. And what else do we want to do? Well, we want to be able to write an entry out onto the screen. So we go void print const. And the way we print out an entry is we go, let's see here, print fixed. Now for the database, well, we know the name buffer size is 10, so print fixed name, and the maximum is going to be name buffer size -1. So fixed width of that much. Then we want to print the single character, the pipe. Do we want a space? No, we don't want a space. And then we want to go for int n is equal to 0 as long as n is less than the value n plus plus, and we want to print out equal signs for as long as equal signs do we want? No, we'll do equal signs. Print. We don't have to print though, do we? We can just put ch. What am I doing here? Put ch. What was this one again? I forget now. It was the pipe. And then we can put ch for the bar graph in the loop, which is going to be our good old friend equals, the key I can never hit properly. All right, so this will print out a single line. Oh, we also have to put out at the end a new line character. So let's go \n. So this will print out a line for the entry. Now, when we want to load and store, we're going to have to load and store each entry. So what we do is we can do void serialize, and we're going to pass in here std of stream, reference to an output file stream. This is going to be const, and we're going to write out to a file stream. So how we serialize is we're going to write out the name and we're going to write out the value. Very simple. So how do we write out the name? Well, there's a bunch of ways we can do that. We do a loop and we can do put, but easier is to just write it out all at once. All we have to do is go out.write and then name, because that's just a car pointer, and then size of name. And then I'll just write it all out. So, I mean, it'll be a little bit of wasted space. If there's only 2 characters in the string, it's going to write out the entire buffer, which is 10 characters. But that's fine. Who cares? I don't care. I'll tell you who doesn't care. Chili don't care. And then we're going to go out.write. Reinterpret cast. Car, probably const car pointer. No, car pointer? Doesn't matter. Let's do car pointer. Address of value and size of value. You could do size of int. Why are you mad? Oh, because this is const, right? So this has to be const. Right. Okay, that makes sense. Now why I could do size of the name of the variable, or you could do the size of the type of the variable. It doesn't matter either way, but name is actually better, because then if I change the type of this from int to something else, like a long, this would automatically change if I use the name of the variable. So it's better to actually use the name of the variable. So here we go. We just write out this and then this. Now, deserialize. We got to do the opposite of this. So void deserialize. And I mean, I could do this in a number of ways. I could actually do it as a, but since we have a serialize function, we might as well have a deserialize. So what I'm going to do is std ifstream in. Now this is not const because we're going to be modifying the object, obviously. And all we're going to do is basically just go in.read name size of name and in.read. Why am I not copy and pasting this? Why am I not doing that? In.read reinterpret cast. This can't be const car because we got to write to it, right? Value, size of value. So we'll just read in from the input file stream. Obviously, for these things, we're definitely going to want our shit to be in binary mode, but that's just, we just assume that it is. If we were wanted to be more careful, we would do a check to make sure that the stream that's being passed in is a binary mode stream, but whatever. So print, serialize, deserialize, create an entry. Good. Here, load, save, print, add. Okay. So first things first, how do we add to the database in memory? Well, what we do is we go entries at current number of entries is equal to entries, or we could just do this. Just do uniform. And the name, pass in the name, and we will pass in the value. And it will construct an entry, put it in there. And we can do this with post increment. So this will, I mean, what post increment does, I don't think I've explained this before, but what post increment does is it returns the value before the increment. So it increments this and returns the value before incrementing. So that way this will work fine and it will get us the proper thing. So add is simply incrementing and doing this. Also, maybe we'll just assert. This shouldn't be an assertion, it should be something else, but for our case, in our case here, we'll just do an if statement. If cur number of entries is less than max number of entries, then we'll do this. Otherwise, we'll do nothing. It'll have no effect, which is fine. Normally, you'd want to do like an error message, but we're not. It's just some dumb homework. We don't want to waste a million years writing it. Print. Print is going to be easy, right? All we do is we go for int I is equal to 0, as long as I is less than current number of entries I plus plus. And then we do entries at I dot print. Seems decent to me. Save. Load. All right, let's do save first. So to save to a file name, first we got to create the file. So std of stream out. File name std ios. Is it base or is it just iOS binary? It's iOS binary. All right, beautiful. Create our output file. We're not going to do any error checking because I don't care, but normally I would. So we create our output file, and then what do? Then we have to, okay, so the file format, we got to figure this out. The file format, I think first we have to output the number of entries in the file. That's the easiest way to do it, in my opinion. So the first 4 bytes will be an int, number of entries, and then all the bytes after that are the actual entries. So saving means first going out.write. Let's just copy some shit. So go serialize. Bam. I'll paste that in here. But it's not going to be value. It is going to be cur number entries. And size of cur number entries. So this will write out the number of entries into the file, and then after that we just got to go for. Now we can be smarter than this, can't we? Just copy this, paste this in here, and instead of entries at i.print, we will do entries at i.serialize, and we'll pass it the output stream, and that will serialize our motherfucker. Good. Saving, done. Loading. What do we have for loading here? Well, it's gonna be the same idea, really. Let's just copy and paste this. See how far we can get with our copy and paste. Just be careful. Copy and pasting is playing with fire. So out, name that the in. We want to do in dot read, and it's got to be in not const char, so normal char. Into the current number of entries, size of a number, that's fine. Then for each number of entries, we are going to go entries at i dot deserialize using input stream. And that, my friends, should be that. This should be everything that we need to get our shit together. But as usual, probably not. We'll see. So here is our database class, our entry class. Let's see if we can't make it do some hot garbage. So, what we want to do here is we want to give the user basically a menu prompt for, so bool quitting is equal to false. Do. So first thing we're going to do is we're going to output a message prompt and print. So the message is going to be L load save add or print question mark. Load, save, add, or print. Put a backslash in on that motherfucker. Now we won't put a backslash in. So we'll print out the prompt, and then we're going to do response is equal to underscore get ch. So we'll get the keyboard button that they hit, and let's do a switch here. So switch on response. It's just another kind of integer type, so we can do that. Case L for load. So So if the case is load, then we want to print another prompt. Print enter file name. And we want to do a \n there. And then actually we want a buffer too. So car buffer 256 const int buff size is equal to, now we don't need buff size, we'll just do size of. Size of is 6 here. All right, so enter file name, and then we got to do chili read buffer size of buffer. And then we're going to do what? Well, we probably want to have our database, right? So let's go database db. It's got to be chili database, right? It's in the chili namespace. So chili database db. So we create our database. And then in here, we're going to read from the buffer. And then we are going to go db.load buffer. Because the buffer is going to contain the file name that the user input, hopefully. And that's it. Break. Now we also probably want to output put ch backslash. That's not a backslash. Backslash in there. I'll put a new line, and then when it breaks, it'll go back up here, because this do is going to have a while not quitting. So for case load, we do this shit. Now for case save, should be similar, right? Save, we're going to do enter file name, read that in, then we're going to do db.save to buffer. It's not save to buffer, save to the file name that's in the buffer. Now the next thing we're going to want to do is add. So case A, print enter name. Read that. And that's going to go into the buffer. Oh shit. We actually need like 2 buffers. So let's just go buffer 2. Sure. And then we're going to copy this, paste it, print enter value. And we're going to read into buffer 2, size of buffer 2. And once we have both of those, then what we want to do is we want to go to db.add. Name is going to be in buffer. The value is going to be chili string to int buffer 2, because that's where the user input for the value was. Add that, and then we put ch for a new line, and we break. That's fine. Now the last thing that we want to do is p for print. And this one doesn't require any input of the user. All we do is we print. Let's go beautiful chart bitches. We don't need space after that. And we'll put another one like this, and this one will just be beautiful chart bitches with underlines and \n. And then what we're going to do is we're going to go, let's put 2 new lines in here, because I'm feeling frisky. And then we're going to do database.print. Print out our database, we'll print out another new line and break. Wait, where's load, save, add, print? We need another one. Load, save, add, quit, or print. So let's add a queue into here. And the queue will just go quitting is equal to true. And then it will break, and then that will break out of here, and then we'll be done. We don't need this because our program is that good. All right, so this should do the prompting and the do-ha and the hoo-ha and the whatnot. Let's see if it is good. I imagine I'm probably going to get some bugs in here. Load, save, quit, or print. Load, save, add, quit, or print. Let's add. Enter name. Dick Cheese. That might be bad, actually. No, that's good. Dick Cheese. Enter value, 10. Load, save, add, or quit. Let's add another one. And the name is going to be pubes. And the value is going to be 23. Let's print. Beautiful chart, bitches. Dick Cheese. Not so good. Not so good. Bad alignment, and we don't have a bar for this one. So we've got a few problems here. We got a few problems. Let's quit a queue. Okay, we quit. All right. So why is this bad? That's what I want to know. Let's try again. Add. Oh shit. That was bad. That was also bad. Let's try again. Add. Pubes. 10. Add. Dick. 23. Print. That worked. Okay, why did the other one not work? That's the question. So we can add more. Value 42. Print. Shit. I think we might have a problem with our thing. So I'm thinking the function that outputs a fixed width is working. However, the thing that lets us input a string is not obeying the size boundaries, and so we're writing into the int that comes after the array here. So I fucked up. That's fine. Where are we fucking up here? I mean, buffer is fine. Buffer is fine. This should be okay. In the add here, the reading part, that should be fine. That should be fine. Where are we going wrong here? Print fixed. This seems like it's working okay because it's printing larger, but that's fine that it prints larger. That's expected. That it will print larger than this W if the string exceeds, but the string should not be exceeding. So the problem is, I believe in string copy. Okay, yeah. So with my string copy, what I'm doing here is I'm copying from this large buffer into where is it? I believe in here? Yeah, into here, which is a much smaller buffer, and that's overwriting the int that comes afterwards and giving me a nasty value. So what I want to do is I want to limit string copy so that it doesn't just keep copying past the end of my buffer. Now there are a few ways I could do this, but I guess the best way is just to make it a safe. I was saying I'm not going to make it safe, but I got to do it. So we go int max buff size, and then we go we'll go int n is equal to 0, and every time we increment we also go n plus plus, and as long as this is not equal to 0 and n plus 1 for the null terminator is less than max buff size. And then here we do this stuff. This should be fine, right? So now wherever we do string copy, which I believe is only here, we have to pass in size of name buffer. Ah, that's wrong. This pointer to name. There. This should work, and it does seem to be working. So let's try it again. We're going to add, we'll enter a nice long name and enter value 23, add, enter a nice short name, enter value 45, print. So far so good. Add, enter pubes 37, add, enter shit, enter name is weird shit, enter value is we put a letter in there. That's gonna be a big old 0, isn't it? Print. Yeah, it's a big old 0. But as you can see, our printing, our adding is now working. Now let's try to save. Save. Enter file name. Let's save it as chart.dat. Print. So far so good. Okay. So we saved it as chart.dat. Let's quit. Q. Now let's see if we can load. So let's run again. And we print. No, nothing in the chart. Let's load from chart.dat. And let's print. Fucking, we motherfucking did it, didn't we? We motherfucking did it. Quit. And there you have it, a nice example of loading and saving binary files. I mean, I'm sure there are probably still bugs in here somewhere if you tested it. And there's definitely, you know, things that you could do to break this. But it's good enough. I'm not trying to build an amazing chart database program here on the console. Just wanted to give you guys an example. And we could add a lot more function to this. We could add a remove function, and that would be able to remove entries by name or something. But nah, we're not going to do that. This is good enough. Working with strings like this is a super pain in the ass, as you can see, with all this pointer bullshit, and it's not the way we're going to be doing strings. This is probably the last time we're going to be working with strings like this. After this point, we are going to be ascending to less bullshit and more fucking kick-ass sexy C++. But I believe that this kind of thing is good experience, and as a well-rounded programmer, you should understand these low-level implementations, at least to a certain degree. As usual, if you have any questions on the stuff that I've covered in the tutorial or in the homework, you know, hit me up on Discord or on the forum, and I will see you soon with some more C++.